Welcome. In this video, we're going to teach you what a rational and an irrational number are. It's a new way to classify all numbers. Every number is going to be considered a rational number or an irrational number. The definition is found in Objective 2 today. It tells us to understand that rational numbers are any numbers that we can express as the ratio of two integers. That's really a fancy way of saying any number that we can write as a fraction, so long as the numerator and denominator, a and b, are integers. To help us understand this definition a little better, we're going to look at a cheat sheet or a graphic. You all have a link to this graphic. If you go to the bottom of your guided practice document today, there's a new table right under the exit ticket called Helpful Resources. And if you follow this link right here for this cheat sheet about classifying numbers, you'll be taken to this graphic here. This graphic helps us understand about real numbers. Real numbers are any number that exists on the number line, and we can split every real number in the world to either rational numbers or irrational numbers. As this graphic shows us, some of the most common irrational numbers are those numbers that we cannot write as fractions. Numbers like pi, decimals that never repeat themselves, and certain square roots. Let's discuss further. If we look at this example problem today, it gives us a bunch of numbers and asks us to classify them. They're either going to be rational, they could be written as a ratio, a fraction, or they will be irrational, numbers that we cannot write as fractions. First one is the square root of 16. It's important to note that the square root of 16 is really just equal to 4. 4 we could write as a ratio, as a fraction. Every whole number or every integer is going to be rational, because they can be always written as a fraction by just putting them over 1. So the square root of 16, our first number, that's going to be considered a rational number. We're going to look at that cheat sheet quick. We see that rational numbers include every integer or every whole number or natural number in the world, because we can always quickly make them into a ratio by just putting them over 1. The next value, the square root of 7. The square root of 7 is not a perfect square. We've been talking about some of those for a week. If I put square root of 7 into a calculator, I see this insane decimal, 2.64575, 2.64575, and it kept going with no pattern. Those are the types of numbers that we consider to be irrational numbers. Some of the square roots, the non-perfect squares that make these decimals with no pattern that never end, are irrational numbers. The reason for that is if we don't know how this decimal ever ends, if it keeps changing its numbers and it never stops, there's no way we could possibly write it as a fraction in the form a over b, where both a and b are whole numbers. 2.25, it turns out any decimal that comes to a stop, any decimal that has a terminating number, is always going to be rational because it could be quickly written as a fraction. 2.25 is the same thing as 225 over 100. See, 225 over 100 gives us 2.25. 3 over 11, that's also going to be considered a rational number because any fraction, by definition, has to be rational. The whole idea of a rational number is, can we write it as a ratio, as a fraction? And this is already in fraction form. Now when we do 3 divided by 11, that decimal is messy, but we see there's a repeating pattern, 27, 27, 27. Any repeating decimal comes from a fraction and will always be rational. The final example we see here, 2.35946, with a decimal that keeps going. That's going to have to be irrational because we have no idea how that number ends. For guided practice today, you had a few more questions about which numbers were rational. Based on the video, you should understand that repeating decimals come from a fraction. Integers can easily be put as a fraction, so that can help you answer these 2 questions. And this is one of those decimals. E is a fancy or important number in the world, and if the decimal never ends and has no pattern, which is signified by these 3 dots, you could answer whether or not that number is rational.